Alright, we're doing this problem called Domino and Tromino tiling. Let's have a read. You have two types of tile, a two cross one and a Tromino shape. Okay, so there is these two kinds of tiles. You may rotate these shapes, okay, so we can rotate, fine. Given an integer n, return the number of ways to tile a 2 cross n board. Since the answer may be very large, return it modulo this, okay. In a tiling, every square must be covered by a tile. Two tilings are different if and only if there are two four directionally adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tile. Let's look at this example. N equals to 3. You took a vertical tile and two horizontal tiles. You took three vertical tiles, two horizontals and a vertical tile. Okay, so one vertical, two horizontal, and two vertical horizontal are considered different. And you could take a Tromino of this and fit it with this, and you can take a Tromino of this shape and fit it with this shape. And so we have these five different ways. So our task is given this and we have to fill this 2 cross n. So one good thing to note here is this 2 is fixed, right? So it will always be this 2. That's good that they have restricted that. So you can only increase in the width. The height of 2 is fixed. Okay. So let's try and see the answers for different shapes or different n. So let's switch to a whiteboard and so we have to solve for 2 cross n. So first let's do n equals to 0. No tiles. Okay, so I mean that's the space case. N equals to 1. There is only again 1 because this is the only way. Right? N equals to 2. Okay, so n equals to 2. That means 2 cross 2. So you either take a tile like this and then follow it up with another tile like this, or you take a horizontal tile and place another horizontal tile below it. So for n equals to 2, there are two ways. And for n equals to 3, in the example that we saw, there were five different ways. And so the five different ways are you take one vertical tile and then you follow the two horizontal tiles. And this one vertical tile could also come at the end. And you add a vertical tile here. Those are two ways. Another way is you just take three vertical tiles, right? So these are from the dominoes, and there are two ways even for Trominos. Like one of the way is this. So you take this and another one this, and the other way is you take this and you fit it up with this. So now how do we generalize it? So for n equals to 3, we get it 5. But like how do we generalize? So how many different kinds of tiles are there? Let's first talk about that. So types of tiles. And we'll rotate as well. So one of the ways is so T1 is just a horizontal tile, and you can also rotate it. So that is T2, and T3 is now we come to different types of dominoes. So sorry, trominos, yeah. So this is one shape, and then you could keep rotating it. So other way could be this, and then you could also have um, something like this, right? And you could also have So this is empty here, this is empty here, this is empty here, which is the missing empty, this one, right? So it's a mirror image of that. So this, so these are six different shapes. Now, if you have to solve for t cross n or 2 cross n, so let's talk about the last tile that completes the, so the 2 cross n, that means some n, and we just finish it up perfectly. Like it fits perfectly. There is no there is no something protruding out, something like that. It is complete, right? So what can be the last tile? What are the different, so let's see, out of this T1 to T6, what are the different last tiles can I have? Okay, so let's talk about last tile. So if last tile is, let's say, T1, if the last tile is T1, what does that mean? That means you either have a this here or you have this here, right? And the only way to make this happen is the other tile also has to be this, and which is like a perfect this, and and so from this, the number of, that means you, this is what, this is n minus 2, right? And this is 2. So if last tile is T1, then the number of different ways would be, if we call it f of n, we are trying to find, number of different ways would be f of n minus 2, right? And if the last tile is T2, okay, if the last tile is T2, that means you have what? You have your filled and you have last tile as this. And so, okay, it's perfectly fitting, and this is what your n minus 1. So then the number of different ways, you just fit n minus 1 and then this you get done. Now let's say last tile is T3. If your last tile is T3, so you take your perfect fit. If your last tile is T3, then last, it will be not like this, sorry. Okay, so basically you can't have last tile is T3, it seems to me, because if this is your last tile, like whatever this you can fill, but like this guy remains empty, right? So T3 cannot be the last tile, not possible. And same for T4, again, not possible. So now let's look at last tile as T5. So when last tile is T5, that means you have your perfect fit, and in that perfect fit, your last tile is something like this. And so that means the remaining shape has to be something like this. And this is not, we don't know what this shape means. So let's call this, this is a shape where uh, extra up is there, right? There is an extra protruding up here. And so this would be, let's call it some different shape, whatever. Let's call this, uh, so this essentially, this is, we don't know what the shape is. We'll call it F, where you have an extra up and n minus 1, right? That makes sense. And last, now let's look at last tile is T6. So we are looking at this shape, and our last tile in this shape is this. That means the remaining portion is this. And again, this is not a complete tile. There is a protrusion at the end. So let's call this guy f down of till n minus 1, right? This is n minus 1, this is 1. So basically, they were out of the six, there are four tiles which are possible, and they give these many different variations. So essentially, what we can say is f of n equals to f of n minus 1 plus f of n minus 2 plus f up of n minus 1 plus f down of n minus 1. Now let's try and build some relationship between this f up and f down as well. Okay, so let's look at this f up. What is this f up? So f up is, all right, let's do, so this is your f up. How can you end up with this? There are two ways of ending up in this. One way is this is a horizontal domino like this, which means that your remaining bit is this, right? Which is, if you notice carefully, this is some sort of up down, right? And the other way would be, you have this, and this is coming because you're taking this and you get this perfect this. So these are the two different ways. So now I'm trying to bring some relationship between. So I can say then f down, sorry, this is f up. So I can say that f up of n equals to, in this case you put this, and this is 2 subtracted, so is f of n minus 2 a perfect n minus 2, or this n minus 1 with the f down, or f down of n minus 1, right? And similarly, let's do our f down. So this is your f down, that means one extra down here. And to be able to do that, there are again two options. One is you take a horizontal domino, that means the other part is this, which is f up, right? So this is f up of n minus 1. Or the other way to do this would be, you have this, and to achieve this you would actually take like this kind of domino, Tromino, and the remaining bit is just perfect n minus 2, right? So this clearly, so from this you can call f down of n equals to, again, f of, sorry, n minus 2 plus, my bad, f up of n minus 1. So like these are the three different relationships we got, right? We got your f of n, we got f of up, we got f of down. So let me write them down. So what are the different relationships? So one is f of n equals to f of n minus 1 plus f of n minus 2 plus f up of n minus 1 plus f down of n minus 1. Okay, now let's expand this f up of n minus 1 and f down of n minus 1. So this is equals to f of n minus 1 plus f of n minus 2 plus, So f of you can route as f of n minus 2. So this is n minus 1. So if you put it here, then it becomes f of n minus 3 plus f down of n minus 2. And this will become what? This will become again f of n minus 3 plus f up of n minus 2. Okay, so let's see what this is. So f of n minus f of n minus 2, f of n minus 3, f up of n minus 2, f down of n minus 2. This is quite interesting. So if you look at it, you can also call it f of n minus 1 plus f of, like this guy, f of n minus 3 plus, now see this, f of n minus 2 plus f of n minus 3 plus f up of n minus 2 plus f down of n minus 2. Now notice this and notice this. Just replace n with n minus 1 and you'll get this, right? F of n minus 2, f of n minus 3, f of n minus 2. So this is essentially f of n minus 1, right? So what this means is you get 2 times f of n minus 1 plus f of n minus 3. This is your f of 1. So we can use this relationship and then solve it, right? So coming back to the problem at hand. So what we achieved with all of that analysis is that f of n equals to, we got this recurrence relation, f of n minus 1 plus f of n minus 3. And we also know base conditions. We can say f of 0 is 1. We can say f of 1. So we have to get till n minus 3. So 3, we have to, so for n equals to 3 is what we can solve. But so 1, 0, 1, and 2 we have to know already. So f of 1 equals to, again, 1, and f of 2 we already checked. There are two ways. So now this is something that we already know. So then f of 3 equals to 2 times f of 2 plus f of 0, which is equals to 5, right? And then we can keep on building up. So essentially for n, I need n minus 1 and n minus 3. So obviously I might probably need n minus 2 as well and n minus 3 as well. Now we could use an O of n space and try to build it, but we can also use just 3 variables, right? Because essentially we just need the last 3. We just need the last 3. For any guy, we just need the last 3. We'll keep updating the last 3. So we'll need, let's say, 3 variables. Int let's call it uh, previous third, right, equals to 1, and previous second equals to what was f of 1? F of 1 is 1, and previous as 2, right? Now I want to do, I want to solve for, so I know till f of 0, f of 1, f of 2. I want to solve for f of 3, so I equals to 3, I is less than equals to uh, I equals to 3, I is less than equals to n, and I plus plus, and obviously I get this. So I have to solve previous, right? So previous equals to I'll save it in I'll saving the result in previous. So previous equals to 2 times previous plus previous third, and so, but you have to save. Okay, let's call it temp. So now this previous is fine. Now I want previous second as this temp and previous third. Okay, we have to shift everything one by one. So this is fine. So previous has to become, sorry, previous is the new guy. I need to save three. So this is the current. You can also call it current, right? Uh, so current, call it previous, and let's call it previous. Just clearing. So now let's clarify things. Current equals to 2 times current plus previous, which is all good. Now current is set. Now previous has to become what? Previous. No, previous has to become temp. So before that, I have to. So this is done. You calculate this new. This is gonna go away, right? This is gonna go away. So previous will be previous. So I know that previous will be temp essentially. So I know that previous will be temp and previous will be previous, right? So is this? Yeah, this is working fine. So you update the current, then you update the previous, and then you update previous. So and at the end you return current. Okay, run code. Okay, and submit. And you get a wrong answer. For n equals to 1, output is 2, expected is 1. Okay, but like why would it solve for like for n equals to 1? Okay, fine. Minor details. So if I equals to what are the different n that I can get? 1, right? So if I equals to 1, return 1. If I equals to 2, return 2. Okay, I got a wrong answer because it's not I, it's n. Submit. And we get a wrong answer. And I think that wrong answer is probably because it's a large value. It said something about this mod. Yeah. So let's add this. So some large value. Okay, let's just put it here itself. Uh, Mod equals to 9 zeros and 7, something like this. So let's do this equals to this into this percentile this mod. Okay, and that's what it failed for 30, I think. So 30, run code. And you still get a wrong answer for 30. Should I try something like this? I don't know. Okay, yeah, this works. So submit. It works. So essentially, I mean, the mod bit is okay, but primarily it was about coming up with this condition, and this condition, this reconciliation is something that was a tricky bit here, and we had to sort of look at multiple things to come to this condition. We had to first check uh, what are the different last yeah, we had to check what are the different last tiles, and then based on that we had to first come up with this relation, which was okay, and after that we had to come up with what is the meaning of f up and f down, and finally build a relationship among everything and come to this final equation. All right.